This meeting is being recorded.
This is the program we're going to try to reproduce in the sample output. Just trying to print out 15 decimals of pi. Okay. File, new, project, interview. This window, source, package, interview for pi. New class, interview for pi. Main module, of course, started off making a variable, assigning a variable, a variable with the double of double for pi, double number equals, and we use the math function, math.pi function. We're going to do a for loop, lowercase, for, and then we're going to do a count. I'm going to just do another variable called count for count equals 0. Just assign it to 0, and this is an integer. This will be an integer. It'll just be a number that'll be incremented by 1, and to do that, we have that here. And as long as count is less than or equal to, we're going to say 14 because that's the amount of times we want. We start, instead of 1, 2, 3, 4, 5 all the way to 14, it starts at 0. And we want to get 15 decimal places, so that's what's associated with the count. So count, as long as it's less than or equal to 14, this loop will continue to go. And then inside the for loop, we need to do a printout statement. But first, I want to create a variable, integer variable called mod, and basically this will be used to like change the decimal place. I'm gonna start off with 2 decimal places. So 2 plus, so add 2 to the count, the current count, and then minus 1. So I guess this will start at 1 at the first decimal place, minus 1, and then system.out. We want to do number and modulus, not in that order though. We're gonna need we need to do this to a certain precision. So in quotes, in quotes, I'm gonna put percentage sign followed by a 0, a point, and I'm gonna put a 1 in front of it. That just means it's gonna be 1 in front of the decimal, and that'll be attributed to the modulus output. This will change this number right here will change like the position of this modulus, and then I will concatenate that with another precision and for the float. So f, and it's a specifier. This will specify the precision, the modulus and n, and then the f because it's a float. I think that's the right way to do this. This needs to be in quotes. Oh yeah, And this print line needs to be printf because we're printing a floating point number. And it went away. Okay, let's see. All right, and it starts at one decimal place and it goes up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I can take off this 1. And then it did 2 decimal places. That actually looks more like the output from the sample output, and it says is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 decimal places. All right, let's do it one more time. File new project, interview 5, enumerate attempt. Interview 5 again. All right, this window, get pi. That's the new, was that a package? I think so. Yes, cancel. Undo, yes. Source code, new package, get pi. Case sensitive. And now a new class called get pi. Main module. And we'll do create a new variable with a double type, lowercase. Startup. This needs to be, both of these need to be uppercase, both letters in pi. 4 needs to be lowercase. 4 for int count. So starting a counter variable, we're assigning it to the value 0, semicolon, count less than or equal to 14 for 15 iterations, and then count plus plus to increment count, to increment the count by 1. And then see, we're gonna need to do an output. So system.out, we want to input output number, and number for sure. And we need to create another variable, another integer variable to increment the precision of the variable. So int precision, PREC. Oh my lord, PRECE, precision. Okay, I don't know. I'm gonna just do mod mod equals, yeah, 1 plus count. I don't know why that red line's still there. 1 plus count. Oh, so each time that this goes, it'll start with 1. So it'll start with 1 decimal place because count is first initialized to 0. Might want to do this to 2 decimal places here and then -1. Modulus and system printout, and we have to work on the precision of this number that we're printing out. So I think the concatenation. So the precision. All right. We're gonna do a float number for number, and then we need a space here. A line separator as well, and that would just be modulus in, and that needs to be in quotes, and that'll be that'll be connected to number, and then here we need a precision of the float, so modulus 1 period, and that just means that before the number that we're printing out, it only go to 1 decimal place, and then we're going to add the decimal places in modulus. We'll increment it by mod. And we're concatenating these together, so these will go together, and this will be incremented by this, and it will be added to this. So mod equals 2. And I think I was missing dolphin tails and another one under the 4, so that everything that's in the for loop will go together. Anything else? Try that. Oh, and this needs to be an F because we're printing out a float. And I think that fixed it. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 decimal places. And it starts at the first place. So I could actually do this to 3. And it'll start at the second place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, okay, so 3 starts at the second and subtract 2. Plus count. And this is changing how, I guess I could add like another decimal if I wanted it to start off at the second one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Just to count. And that's not pi though. try to 15 here. No. Oh, I can set count equal to 1. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's it. That's it.